Hello everyone, we are going to solve the Koko Eating Bananas from the Strivers A to Z DSA course, which is based upon the binary search on spaces. So first we need to know what the meaning of Koko Eating Bananas. So it is given the n piles and the ith pile basically given an array, and in the array the ith pile has a of some bananas, and the Koko must eat all the bananas within a stimulated time of given the stimulated time as h hours. So we should find the minimum speed with which the Koko can eat all the bananas within h hours. So let's take an example and understand that. So given there are 4 piles, so there are 4 elements in an array. So each pile here this pile has 7 bananas, this pile has 15 bananas, 6 and 3. Then it should eat all these bananas in 8 hours. So we should find the minimum versus speed. First we assume if we take randomly as 5 bananas per hour, 5 bananas per hour, how much time does it take? So it will complete, if the value is 7, it can complete 5 bananas within 1 hour, and it require an additional time to complete the rest 2 bananas. So we assume it has 2 hours, and if it eats 5 bananas in an hour and then 2 bananas in another hour, so if it completes even before that, it will be stay at rest. It doesn't eat any further bananas in the 2 hours. Then if we take this, if the speed is 5, it takes around 3 hours to complete this. Then for this it will take around 2 hours, and for this it will take only 1 hour. So what's the answer for this? Its answer is, this is 5, 7, 8. But how to figure out this? We can complete this in 8 hours. Total is 8. So at max we can have it as 8. We should complete this in 8 hours, and we are getting total time as 8. So we can assume that we can have a speed of 5. Can it be less than that? So we need to check it. So how to get this answer? How to get this 5? We can't randomly get the answer. So how can we get this 5 or any other as our answer? What should be our approach? If we are going to discuss binary search on spaces, we need to know what are the our possible answer lies in. What's the range for it? For this, the Koko should eat at least 1 banana. Without that, he can't stay at rest. In 1 hour, it should eat at least 1 banana. So the minimum is 1. And what's the maximum? Or at maximum, what's the speed? If it eats at 15 bananas per hour, assume it eats 15 bananas. Here it eats 7 bananas in 1 hour, and it can stay at rest for the rest of the time, and then it takes here 1 hour. If it eats it, then it takes 1 hour, and then it takes 1 hour, and then it takes 1 hour, total of 4 hours. But what's the speed here? 15 bananas per hour. But what we need is a minimum speed with which it eats. So we need to find the minimum speed. How we can find the minimum speed? That's our case. So our answer definitely lies in between 1 and 15. So even if we take 20, it will take 1 hour, 1 hour, 1 hour, 1 hour. We can't reduce our time less than 4. So if it takes a maximum value in that, it will be the speed of that. If we cross check it, try it yourself and get the how we have taken 15 as our maximum. So we get as 15 as a maximum. So our answers should lie between 1 and 15. So our answer space is 1 and 15. And what will be our answer? We apply binary search and let know. So first, what do we need to do? We find the mid value. Mid value will come it as 8. So we'll check for 8. We take as 3, 2, sorry, this is not the answer. 7, 15, 6, 3. we take the speed as 8. So when we divide by 8, and we need to seal that word. If we get it as 1, we'll get as 2, we'll get as 1, we will get as 1. So how much time it takes? 3, 4, 5. It takes 5 hours, which is less than the given hours. But what's the speed is 8. Our speed is 8. Can we have, what's our goal? We should find the minimum speed. So if you can eat at 8 bananas per hour, we can complete in 5 hours. So if we what if we decrease the speed of this, we can, our answer or hours will get a higher value. But we should get a higher value than this, but it should be less than or equal to 8 hours. It shouldn't be exceeding the given time. It should be less than that given hour. So what we need to do, we should, our answer space is this 15 and 1, our 8 lies here. What we should do, we should eliminate, we should eliminate, as we require the minimum speed, we should eliminate this search space. So we get 8. What's 8? For 5 hours. We need to find the minimum speed. At this, we are getting the answer. The Koko can eat all the bananas, but this may not be the minimum speed. What we require is a minimum speed. So we shouldn't, if we search on the right, if we apply binary search on the right, we may not get our answer. Why? As already here it gets 5, it may get 4 here, it may get 3 here, but it's the speed increasing and the time is decreasing. But what we get the minimum, we should get the minimum speed, and time is at most h hours, given h hours. So we should eliminate this search space, search space and search on this. So let us look how we can do it. So here we got it as 8. Then we apply binary search, and here it's a mid, assume it as mid. It will be high, it will be low, and when we are moving this, our high moves to the one place before the mid. So our low becomes 1, high becomes 7. Did you get it? So our low becomes 1, high becomes 7. So when you calculate the mid, our answer space is now this 1, 7. This is our answer space. So we should find a optimal value or answer in this range only. We shouldn't consider these values here. It's consider here only. So it's 1 and 7. 1 and 7. So what will be the answer? We'll calculate the mid. We get it as 4. So we will try it for 4. What will get it? So it is 7, 15, 16 and 6 and 3. So when we divide this by 4, we are getting 2, we are getting 4, we are getting 2, we are getting 1. So what's our total time taken? It's 6, 8 and 9, which is greater than h, but we should complete within the time. So our answer space, our answer, if it assume it is a 4 here, our answer will not be lying here. If I take a lesser speed than this, if I take a lesser speed than 4 or equal to 4, I will be getting a higher time than the required hours. But our case should be minimum speed within the given time. Minimum speed. So we should find an answer. We should eliminate this space. So if we find in this space, there is no use, because we'll get the time required. The time will be higher than the given HRs. But we need to find within the HRs now. So that's why we need to eliminate this. Now our new search space becomes 4 and 7. When we take the middle of it, when we calculate the mid, we get as 11 by 2. We get as 5. Yeah, we get as 5. How then? What we should do? Then we'll check for it. 2, 7, 15, 6 and 3. When we calculate for this, we get as 2, 3, 2 and 1. Then what's our issue? It takes 2 hours to complete this. It takes 3 hours, it takes 2 hours, and it takes 1 hour. So total it will be completed in 8 hours. Our is H is 8. So we can take this as our possible answer. But if we get an answer here, we shouldn't stop here. We should continue till the low is this. When this condition is failed, we should stop. But we are at 5, at 6. So this may be our possible answer, but we can't finalize as of yet. Then we take or reduce our search space, so there is no use of this. So we have found the answer here, so there is no use of this. Then what we'll do, we'll take it as new search spaces 4. At least it becomes the high B will become and mid and everything will point to this. So low, mid and high, everything will be light pointing to this. But we will check for this. What will happen if we do for 4? Already we did it now. If mid is 4, we can't have it. We can't have the answer. So let us do it again if you want to do it. So we'll show it here. So 7, 15, 6 and 3. When we divide by 4, we get is 2, 4, 2, 1. But what's our, it will getting us 9. So this is not our answer. Then our low should be moved to the mid plus 1. It should be moved to the mid plus 1. When this moves to the, when the low high stays here at 4, but low moves ahead of high, this condition fails. This condition fails, and we stop the binary search there, and we just return our answer, which is 5. So for what we got is as 8. It is for 5 we got it as 8. That's why, that's the reason we just get the answer as 5. So for this problem the answer will be 5. So I hope you got this solution. If you have any doubts, please comment it.